Inside cars, cell phones, computers, and more, you will find magnets that make them all work.
They are also key to the technology that will unlock the clean energy transition. Tonight, WCCO's Caroline Cummings takes us inside a Minneapolis company that is manufacturing magnets unlike anyone else.
From consumer electronics to carbon-free energy makers like wind turbines. Inside, you'll find permanent magnets that power so many of the products we rely on every day. And many miles from Silicon Valley near downtown Minneapolis,
She's going to make nanoparticles.
one company is daring to create them in a way that could set off a chain reaction across the globe.
The enthusiasm that we have to develop this technology and make this difference is what honestly attracted a lot of people here.
Including Frank Johnson, the chief technology officer of Niron Magnetics. Its name gives clues. The main components of the startup's proprietary technology are iron and nitrogen. After more than a decade of research and development, Johnson says they've discovered something special, how to use those two elements and make magnets without mining rare earth materials that can be hard to come by, depending on what's happening around the world.
There will always be these types of potential supply chain disruptions whenever we have materials coming from overseas. Preferable solution in my mind actually is just to have a source that bypasses those by taking advantage of technology to try to solve this problem.
Right now, China controls 90% of production of the world's permanent magnets. And more than a decade ago, when a dispute with Japan halted shipments to that country, there were cascading impacts beyond their borders. That's when the United States started funding projects looking at alternatives. A professor at the University of Minnesota took it on, and eventually his ideas transformed into Niron Magnetics.
I don't know if you ever remember the periodic table from chemistry class. If you look down
I
at the
thought I
bottom.
blocked that out of my brain.
Yeah. Well, everybody did, as it turned out, and this kind of brought it back to everyone's attention.
So let's go back to high school for a second. All of these elements are rare earth elements you have to mine to get, which can be challenging, costly, and damaging to the environment. But Niron Magnetics magnets use iron and nitrogen, two of the most abundant elements on Earth. As demand for clean energy and technology grows, demand for permanent magnets is expected to soar and will outstrip supply in the next 2 decades.
The iron nitride compound itself is fundamentally a stronger magnet than the rare earth magnets. It's about 50% stronger. The challenge is getting all of those properties in a product.
Inside this lab is where they put their magnets to the tests. A team of specialists analyze how they work and how they can be used in consumer products as the company readies to launch its first magnet prototype for product developers that would use it.
This is really just nanoparticle rust. It's iron oxide. So we start out making nanoparticle rust, and then we take the oxygen out, put the nitrogen in, and in a very specific crystal structure, which is very difficult to make, that we've figured out how to make in volume to get this material.
And that's the basis of your magnet.
Correct.
Pete Ladwig, Vice President of Nanoparticle Technology, says they take that special magnetic material and compress it into magnets like this. Eventually, maybe finding their way into cars, cell phones, stereos, and more all around the world.
Do you think this technology is as important as something like the light bulb?
Yes. We wouldn't be able to do many of the things we do today without permanent magnets.
With photojournalist Mike Durenberger, Caroline Cummings, WCCO News.
Niron Magnetics' Minneapolis facility is the company's pilot plant. It's building a commercial-size operation in Sartell that will allow it to produce millions of magnets.